Tonight's video lecture is on formula weights and how to determine those from formulas for ionic and molecular compounds. When we think about formula weights really describe the weights of the atoms in a chemical formula. The example here is calcium chloride, CaCl2. There's 1 calcium in the subscript, 2 for chlorine. So we multiply the atomic mass of calcium by 1. We have to multiply the chlorine atomic mass by 2, and then summing together we get a formula weight of 110.99 AMUs. AMU stands for atomic mass units. Later on we'll talk about how that relates to grams and stoichiometry. Formula weights are generally reported for ionic compounds, so you have metals and you have nonmetals when you do that. Molecular weight is usually reserved for compounds that are molecular with 2 nonmetals together. So in this case, this is C2H6 ethane. So you take 2 carbons because there's a subscript of 2. There are 6 hydrogens in this case, so you multiply it by 6, summing together to get 30.070 AMUs. And it's the same process as ionic. The only difference is when we say molecular weight, we're dealing with covalently bonded things or things with 2 nonmetals. Example-wise, thinking about how this looks, if we were to take a compound which would be calcium nitrate, and we were trying to find out what its formula weight was, this is ionic. So you start to look at the calciums. When you look at calcium, there's 1 in the formula because there's no subscript. So we would multiply that times its formula weight. I get my multiplication sign here. And its formula weight is 40.01 AMUs. And then with the nitrogens, we have 2 of them in the formula. So we have to multiply 2 times its formula weight, which is 14.00. So we get 28. And then with oxygen, since that 2 goes to the polyatomic ion, it's like the distributive property. So there's not just 3 oxygens, there are 6 oxygens. So we have to take 6 times the formula weight of the oxygen, which is 16. And when you put that together, you get 96. So when you add all those together, the total formula weight of this calcium nitrate is 164.1 AMUs by summing it together. So again, you look at the subscripts and see how that pertains to it as we move on. All right? So that's how we can solve that. The next item we've got on the list is percent composition. So this is very similar. This is very similar to thinking about how we put together for the percentages and the compounds. So when we put these together, we want to find out how much of the whole are each element. So here's the formula below, the number of atoms times the atomic weight divided by the total formula weight of that compound. So very similar in terms of the process. Here's an example of the percent composition of carbon and ethane, which we just looked at. It had 2 carbons in it, so you multiplied it by 12.011 AMUs divided by the total. When you divide that out using significant figures, you get 5 significant figures, 79.887% carbon. You can do that by mass. You want to round by significant figures. So percent composition always should add up to 100. Make sure that you use the significant figures correctly whenever you're rounding to the right number of decimal places. We'll stop there with the lecture, and then we will do moles tomorrow.